It's week 5. So today we're going to talk about electromagnetic waves. We have discussion post that's going to be posted in a moment. Also, analog digital signals investigation 2 is due, including the stemologist's career in science and technology due. Okay. This week we have electromagnetic waves investigation. Same pattern as last week, but we're going to talk about electromagnetic waves. That's part 1. That's due Friday. Ed Puzzle today is going to be posted. That's due Friday as well. And then, of course, discussion post Wednesday. Thursday is investigation part 2 of the EM waves. And then Friday we have quizzes. Okay, so that's going to be our whole week this week, and we're going to get going. So, electromagnetic waves. Oh, by the way, it's May 4th. Get it? May the 4th be with you. Ah, all right. So,
yay!
Hey, no one's going to laugh at me. That's fine.
Okay. I'll laugh at you, Mrs. White.
I know, right? Yeah, I know. That's why you're my crew. All right. So, while we watch in this little video that has to do with radio waves, list down some benefits of radio waves and its uses. Why do you think learning this is important? So the video is going to give us an information about radio waves, which is an example of electromagnetic waves. All right, so let's take a look at that real quick, and we're going to get going.
Guglielmo Marconi's first radio transmissions in 1894 have spread into space for over 100 years at the speed of light. They passed Sirius in 1903, Vega in 1919, and Regulus in 1971. That signal has already passed over 1,000 stars. Anyone orbiting one of those stars with a really good receiver could detect Marconi's signal and know that we are here. Radio waves are the longest and contain the least energy of any electromagnetic wave. While visible light is measured in minute fractions of an inch, radio waves vary from about 19 centimeters, about the length of a water bottle, to waves the length of cars, ships, mountains, all the way up to monstrous waves longer than the diameter of our planet. Heinrich Hertz discovered radio waves in 1888. The first commercial radio station went on the air in Pittsburgh, Pennsylvania on November 2nd, 1920. Then, in 1932, a major discovery by Carl Jansky at Bell Labs revealed the stars and other objects in space radiated radio waves. Radio astronomy was born. However, scientists need giant antennas to detect weak, long-wavelength radio waves from space. The enormous Arecibo radio dish antenna measures 305 meters in diameter, over 3 football fields. Scientists can link the signals from an array of separate radio antennas to focus on tiny slices of distant space. Such arrays act as a single immense collector. This giant New Mexico array uses 27 parabolic dish antennas shaped into a giant Y, with each arm capable of stretching for 13 miles. Scientists have even spread these linked antennas across the globe. One of the largest stretches from Hawaii to the Virgin Islands and acts like such a powerful telephoto lens that a baseball sitting on the moon would fill its entire field of view. Many of the greatest astronomical discoveries have been made using radio waves. Pulsars, the existence of giant clouds of superheated plasma, which are among the largest objects in the universe, and even quasars, such as this one over 10 billion light years away, were all discovered using radio waves. Radio waves also provide more local information. Astronomical objects that have a magnetic field usually produce radio waves, such as our sun. Thus, NASA's STEREO satellite is able to monitor bursts of radio waves from the sun's corona. Wave sensors on the WIND spacecraft record the radio waves emitted by a planet's ionosphere, such as the bursts from Jupiter, whose wavelength measures about 15 meters. Radio waves fill the space around us to bring entertainment, communications, and key scientific information. We can't hear these radio waves. When you tune your radio to your favorite station, the radio receives these electromagnetic radio waves and then vibrates a speaker to create the sound waves we hear. We may not be able to tap our toes to the cosmic radio transmissions, but we certainly discovered much about our universe's grand cosmic dance by listening to them.
So before we get going, please list down some benefits of radio waves and its uses. And then I'm going to call in some of you guys to mention some. So I'll unmute you and let us know one benefit or one use when it's your turn. So let's start first with some benefits. You can write it down in your notebook. If you're ready, click the raise your hand button and let us know so I can unmute you, or Mrs. Watkins or Miss Tracy will unmute you to tell us one benefit of radio waves. Let's take a look at the first one. Who would like to share to us? Anybody? Okay, Luke. Let us call Luke. Can you please tell us one benefit of radio waves?
They can be used for us to communicate with each other over long distances, only because these waves stretch the longest.
Perfect. Very good, Luke. And your voice is very loud, but we can hear it very well. Thank you. Let's call two more students. We have Mary. Let's call in Mary.
Oh, we could find aliens.
We could find aliens. Yeah, that is true. Let's have one more student who would like to answer for the benefits of radio waves. Yes, Mimi, I unmuted you.
It contains less energy, so it uses less energy.
It uses less energy. Yes, that's correct. And that being said, one of the important use that we know about radio waves is what? What is one use of radio waves that we know of? Anybody?
You could type it in the chat or you could raise your hand.
Type it in the chat if you don't want to talk, but you can type it in the chat. Tell me one use of radio waves. And I think I have Danny raise her hand. Go ahead, Danny, and let us know you're unmuted.
It's used to reveal objects in space.
Yes, that's perfect. And thank you. And Charlie, let's call one more Charlie.
So we can listen to any communication.
Any communication. And of course, AM radio is also an example of medium that, of course, uses radio waves to get that signal from our radio station. Yes.
Sirius came in too. Did you guys hear that? In the video, they were talking about the star Sirius. That's why if you have that XM radio in your car or on your cell phone or on your computer, that's what they named it after.
Yes.
The dog in the sky, the star.
Yes, exactly.
About that.
And I think we have some answers here from our chat. We have Brooke says remote controlled toys. Jolie, scientific discovery. Yes, that's perfect. And what else? One more from Edgar, enabled better navigation on aircrafts and ships.
Ooh, that's a good one.
Yes, that's a good one. Thank you for sharing. So electromagnetic waves are transverse waves. Last time we talked about transverse and longitudinal waves. It's a transverse wave, so that's actually how it moves without a medium. So that's the difference between mechanical waves and electromagnetic waves. Electromagnetic waves can travel through space. It doesn't need a medium in order for it to travel. Sound waves needs a medium in order for it to travel, so the mechanical waves, but the electromagnetic waves does not have. But the movement of electromagnetic waves is a transverse type of wave movement. Now, another unique thing, yes, Mrs. Watkins?
Yeah, I wanted to clarify or just re-remind us, when you say medium, she can be talking about lots of different things, right? Medium could be, it can go through your body, it can go through a wall, it can go through the water, it can go through the air. But the whole point of when you're in space, the reason we're in a vacuum means there is no medium. So it can still travel even though there's not something for it to travel through.
Yes, exactly. And that's the ability of electromagnetic waves. Now, electromagnetic waves, the reason why it's called electro and magnetic is because they found that electromagnetic waves, as they travel as vibrations in electrical and magnetic fields. So it means it has two characteristics, electrical and magnetic characteristic of these waves. But it has magnetic and some electric properties to them. Okay? And which is why later on we'll find out about the energy that it could pass on to objects if they radiate something in terms of how much frequency and wavelength they have. Okay? So here's another representation of the properties of electromagnetic waves as electric and magnetic at the same time. Now, electromagnetic waves travels very, very fast, and it's around 300,000 kilometers per second. So that is the speed of light as another term for it. So speed of light is equivalent to 300,000 kilometers per second. So this speed, they can go around the world 8 times in 1 second. So that's pretty much how fast electromagnetic waves travel. Okay, so that's just some extra information. So the speed of light can actually go around the Earth 8 times in a second. So let's do some math. So,
and it takes about 8 seconds for light to come from the sun too. 93 million miles away.
Right. And so let's do a little math. So if a speed of light, if this speed can go around the world 8 times in 1 second, how many times if it's about 15 seconds? Let's see some math wizards here. In 15 seconds, how many times did it go around the Earth? Put it in your chat box and see who got the first one. Emiliana said 75. Is that right? So 8 times in a second. So 8 times 15 is what? Jay said 120. Yes, it's 120 times in 15 seconds that electromagnetic waves would have traveled already at 120 times. Okay? So electromagnetic spectrum is the name for the range of electromagnetic waves when placed in order of increasing frequency. Later on, Mrs. Watkins is going to do a mnemonic challenge, so hang tight on that. But the name of the range of electromagnetic waves is placed from the least amount of frequency to the highest amount of frequency from left to right. So if you notice, radio waves, which we saw in the video earlier, had the least amount of frequency. And then to gamma rays, if you notice the waves down below, if you can see on the diagram, there's longer waves for radio waves. And as you go towards the right, by the time we reach to the X-ray and gamma ray, the frequency is, or the gaps in between the waves are nearer to each other. And then the frequency becomes higher. So it means that it is increasing frequency from left to right. And this is your electromagnetic spectrum: radio waves, microwaves, infrared, visible, ultraviolet, X-ray, and gamma rays. Now, in our investigation this week, we're going to take a look at each of them in specifics. Now, notice the wavelength in radio waves are long. So if you look at the exponents, like the scientific notation, radio is 10 to the third power. So it means the length in between, when you measure the length in between waves, is farther apart from each other. And as you go to the right and you look at starting from ultraviolet all the way down to gamma rays, the wavelength gets shorter. So this is the characteristics of your electromagnetic waves. And the shorter the waves are, they have more energy. And yes, Mariana, that's correct. Shorter waves have more energy. So later on, I'll ask you a reason why we only can do X-rays once a year, can't have a frequent X-ray visits. Why is that? So we're going to find out also as we go along with our investigation. Okay, so here's another representation of electromagnetic spectrum, which shows us some perspective of its size and some common names that we know about and some sources of electromagnetic waves. So we'll start first with your radio waves. So your radio waves can be as large as the soccer field. So that's how far it is, or as far as a house. And also we use that in radios, AM radios, FM radios as well. Okay. Now the microwave oven, it's kind of like in between radio microwaves, and it's towards the microwave. So we use that pretty much most of the time when we heat our food. So that is, of course, microwaves. Now radars are also some examples of microwaves. And if you look at the size of the wavelength of microwaves is about like as big as a baseball. So that's why when you are confined in that microwave oven, it heats up the food, and the wavelength that radiates towards your food is about that size of the baseball. Okay. And also infrared. So the infrared, as you go towards the right side is the infrared. We know that the infrared, some examples of that is your thermogram. It kind of like gives you an image. Later on, you guys will see some examples of infrared waves and also visible light. So the visible light is what we see, okay, with your Roy G. Biv. What's our color spectrum that is visible to us? Can someone put that in the chat? What is our Roy G. Biv colors? Anyone? So that falls under, yes, Mimi, that's the rainbow. What are those different colors? Visible light is an electromagnetic wave, and it's found in a spectrum. So we got red, green, blue. We're missing the O. What's the O? We have orange. Yes. Okay. G, B, I, and V. What is I? Logan, there's no aqua. Indigo and violet. Yes, Adriana, that's correct. Now, right after your visible light is the ultraviolet light. If you notice, the size of the wavelength is about the size of a virus, like the coronavirus. So it's very, very small and minute. We know that your ultraviolet rays come from the sun. And the reason why we want to wear sunscreen is because that ultraviolet, it's very small of a wavelength and the frequency is higher. And therefore, it carries a good amount of energy that could damage our skin. And of course, we know that if we damage our skin, we are more susceptible of getting skin cancer. Now, going towards a little bit more to the right is our X-ray. So X-ray is, the wavelength is very small. If you look at the size of it is about the size of a protein, and that's microscopic, then you know that what is the reason why we can't have X-ray as often as we want to, mainly because of the amount of energy that we receive whenever we do perform X-ray procedures. It could actually damage because it penetrates the bones when we get exposed to this type of waves. So that is your X-ray. And going to the most extreme right is your gamma rays. Your gamma rays, these are radioactive elements that we use in gamma rays. It contains a large amount of energy and therefore very, very dangerous. And in our investigation, you will find out why this type of wave is very, very dangerous. And that's what I want you guys to find out this week, okay? Also, in your Ed puzzle, they'll explain to you guys the electromagnetic spectrum and the characteristics of each types of wave, okay? So just a brief summary of what we need. But we have a question here. Let me read first from Edgar. Where does 5G fits on the wavelength? Is there anybody who would like to think about that? 5G. 5G is the intensity of the signal, right? Mrs. Watkins, do you have any idea about this 5G that fits in the wavelength?
No, I'm curious to see what they have to say.
I am too, but I can answer, but
No, I think we should maybe let them think about that a little bit and get back to us on the chat on when you post this video.
okay.
Have that discussion. Like, what's the difference between 4G and 5G? And like, why is that a big deal? Or why does it matter when you're in a certain location and you're like, hello, where's my signal? Hello. Why do people stand by the windows when they're trying to get a signal?
It's
like, does that actually help? You're on mute, Mrs. White. Oh, I said, you were saying or agreeing. I couldn't hear you.
Yes, I'm agreeing. That's great. So if you wanted to find that out, then go for it. Otherwise, towards the end, I will explain that. If there's anybody who would like to share, put it.
No, don't tell them. They can Google that. Explore themselves.
Google that.
Go find out.
Okay, well, sometimes they want to hear.
Whose question was that, Mrs. White?
It was Edgar's.
I want to check in with you, okay, Edgar? So we're going to check on Google Classroom and look that up together.
Yes. And
I'm not telling you. And Mrs. White shouldn't tell you either.
Okay, but let's just have a brief summary of what important stuff we need for this week. That all electromagnetic waves travel at the same speed, which is 3 times 10 to the 9 power meters per second in a vacuum. Now, they all have different wavelengths and frequencies, and the longer the wavelength, the low the frequency is. Short wavelength, highest frequency. And the higher the frequency, the higher the energy your electromagnetic waves, of course, possess. Okay, so I have here, Nemo said, sends more waves because the 5G has more waves, and it's bad for the body because it sends waves to our body. That is possible, but it's a very minute amount. But again, Mrs. Watkins did not want me to share the answer, but I want you guys to find that out. Otherwise, 5G, 4G, it has to do with the strength of the signal, okay? And always remember that radio waves, microwaves are the ones that your cell phones receive. First part of your investigation, you guys will be reading about electromagnetic waves and what waves or how we connect that with what we learned about the properties of waves. You guys will be watching a video about the nature of electromagnetic waves, and also you'll get to know each one of the waves. So the video will discuss about radio waves all the way to gamma waves and what are those benefits and also downsides of the waves. And also, the third part of your first investigation that I'll post tomorrow is going to be a visit to NASA to research about electromagnetic waves. You will be looking through the electric and magnetic properties of your electromagnetic waves, as well as, once again, comparing the strength of energy and frequency of your waves for each of the waves. Now, on Thursday, the second part of the investigation, you guys will do a virtual lab. So the virtual lab is going to be, you're going to click the link. It's going to be a flash player. So it means you have to enable the flash in your computer, and you're going to do a virtual lab. And then you're going to answer some questions and note down, again, what trend you've seen as you perform the virtual lab. Sort this, just tell me this example, what type of electromagnetic waves it emits. And lastly, draw it. So you're going to choose 2 examples of electromagnetic waves of an object. You're going to draw it, and you are going to describe the amount of energy in terms of its wavelength and frequency. So that's going to be our investigation for the week. Okay, so let's take a look at our mnemonic challenge. It's Mrs. Watkins' turn now.
Yay. Almost done. Okay. So, first of all, I don't need to share the screen or anything, but if you unshare, then we can make this a little bit bigger, Mrs. White. Or no, hold up that. Never mind, that's perfect. So again, this is our radioactive, our electromagnetic spectrum, right? Radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays. So the challenge is to chunk the information. In science and math and history and everything, there's only so many things our brain can remember. But there are certain ways to trick your brain or to hack your brain to code and encode information within a shorter space or period of time. So right now, instead of all those words, all those big words, all that information, what order does it go in? I don't know. It's confusing, blah, blah, blah. Let me help you figure that out, right? So we look at this, there's 3, 6, 7. There's 7 different terms here. And what you want to do is you want to try and make up a statement or make up a phrase. So maybe you've heard when you did the taxonomy in 7th grade or 6th grade, maybe you heard for the different order, King Henry, what was the King Henry acronym, right? Or kings play chess on Fridays with green spiders. King Henry died unexpectedly while drinking chocolate milk, you know, righty-tighty, lefty-loosey, you know, just different ways to help you remember acronyms. Try and make up one for the electromagnetic spectrum. So this was about probably before you guys were born, almost 15 years ago, I made this challenge to some students. And to this day, I still share this challenge. And so when Mrs. White was mentioning electromagnetic spectrums, I'm like, pause, I have to include this because it's the best acronym ever. All right, so I really didn't like it when it first came out because I was very confused, but now I can't get it out of my head and it's amazing. All right, let's go. So first of all, radioactive mice. So there's a mouse and he's radioactive. Radioactive stands for radio. Mice stands for microwaves. I guess it could have been mouse also, but she said mice because it could be plural. Radioactive mice. What do radioactive mice do? Well, they interrogate. That's like a chair in the police office, right? Like think about the light. Somebody's going to go on the chair. So what is the radioactive mice interrogating? Let's find out. He's interrogating a violent unicorn. The unicorn is violent. Look at his eyes. He's so angry. And he has like mad eyebrows, right? He's a violent unicorn in the interrogation chair. So again, radioactive mice interrogate violent unicorns. And how are they going to do it? Does anybody want to see if you can guess? The last 2 acronym letters that we're looking for are X and G. Sometimes X is kind of hard to rhyme with, so you just use what it stands for. So we did it with X-ray guns. X-ray guns. So putting it all together, right? Putting it all together, you have this. A radioactive mouse interrogates a violent unicorn with an X-ray gun.
Awesome.
Electromagnetic spectrum in order.
We want to hear that. We want to see that when we post it on Google Classroom and then type it in. It has to be kind of like a statement, just like what Mrs. Watkins mentioned, and not just some random words, so that you would be able to remember the order of your electromagnetic waves from the lowest to the highest frequency. For this week, discussion post Edpuzzle today. Tomorrow is the start of your investigation on electromagnetic waves. Discussion post is due on Wednesday. Continue the first investigation on Wednesday. Thursday, EM waves part 2. And then Friday is when Edpuzzle is due, and quizzes is going to be posted on Friday. And following week, investigation 2 is due and quizzes is due. Now, some of you do not take advantage of the unlimited tries for quizzes.
Oh my gosh, that's my favorite.
So I don't know why some of you still get less than 70. Please keep trying until you get 100 points. Because
keep it 100, guys. Keep it 100.
If last time I just gave you 2 tries, I gave you unlimited the whole entire time until from Friday to Monday. So please take advantage of that. Consultation hours are on Thursdays, so please make sure that you come in. I don't see anybody rarely. So if you need help, I am there. I'm just there logged in with nobody to talk to. So
it happened to me too. What the heck? Come visit us, guys.
No, visit us. Hang
Ask questions.
Maybe we can play some games or whatever.
Yeah.
You've already
get some help with extra credit.
Exactly. Thursdays, Elena, is our consultation hours. All right. So if you don't have any questions, or if you do have a question, please write it down on the chat. And if you don't, and if you're ready to complete your assignments today, you can show your way out by hitting the leave meeting today. And I appreciate you guys coming in. And next week, I'll see you again.
Yay.
May the 4th be with you. Hi, start of week 5. Sorry we missed you in our live session today, but this week you guys will be learning about electromagnetic waves. Today I posted Edpuzzle and discussion post. And this week, you guys will be doing investigation on electromagnetic waves and the types of electromagnetic waves. So Tuesday through Thursday is the investigation, and on Friday is quizzes about electromagnetic waves. So hope to see you guys next week on our session for Science Live, and I'll see you then. Bye.